Hello, good morning, good afternoon, good evening, whenever you watch this video in your home offices. Here at EANTC in Berlin, it's beautiful springtime, Easter holidays, and it's still very empty in the streets while we're continuing our podcast style series of reports and live demonstrations from the Multi-Vendor Interoperability Event, which we have conducted a few weeks ago. Now, the major area of testing was, of course, the transport network innovation with SDN, with EVPNs, segment routing, and everything around it. However, one very special area, which was much closer to the physical layer, was FlexE. And the FlexE testing was supported by ECI, by Huawei, and by Keysight with the emulation. Now, let's hand over, without further ado, to Elea Sigele from ECI, who is going to introduce us to this topic and to the multi-vendor interop testing. Over to you, Elea.
Good day, remote viewers. My name is Elia Sigele. I work for ECI Telecom, and I'm taking part in this EANTC 2020 Interop test here in Berlin. And today I will present a live demo on FlexE channelization and physical isolation. Just a background, 3 companies are taking part of this. Ourselves, ECI, Huawei, for the test equipment, Keysight. Just a background on what is actually FlexE. FlexE started actually in the data center, and the optical interworking forum decided, this is something brilliant, so let's make it a standard. What we are doing now is that we're implementing the FlexE 2.0 of the OIF. Basically, it's Ethernet, but what happens is that there is a new layer between the MAC and the PHY, and this is the shim. They call it the shim. So FlexE is actually in between layer 2 and layer 1, so we can think of it as layer 1.5. So it's this layer in between the MAC and the PHY. And what it does is it's actually TDM-like manner which it transmits Ethernet from A to B. And what it does, the advantage is that it is low latency and basically delivers deterministic packet delay variation. At the moment, because of 5G, we saw that there is an application actually for FlexE in the transport networks because it isolates traffic between tunnels because of its TDM-like qualities. So what are we demonstrating? We are demonstrating the FlexE channelization capability, or industry term, we are calling it network slicing or hard slicing, to be specific. It's hard isolation, so there is channelization, which means that there is physical separation between the Ethernet flows in one physical interface. In this case, it's one physical 100 gig interface, which is a back-to-back connection from Huawei and to our kit, ECI. And on the other side would be the connection to the test equipment, which is ECI. So what we did last week, and we are doing here, is a live demo of what we did last week, is that we did 2 test cases. And you can read about these 2 test cases, the details of these test cases, in the coming up white paper, which will be published soon. So just to note, we did 7.1 and 7.3. I'm not sure if it will be the same number, but that's what we did with the FlexE. But for the live demo, we will show you the physical isolation of different FlexE tunnels. This is what we are going to do in the live demo today. But last week we also did a dynamic bandwidth adjustment scenario on this FlexE. The details of this test case will be shown in the white paper. Now we will talk about the topology setup. So what we did is that we connect ECI and Huawei with 100 gig eFlexE link between them. And between Huawei and Ixia is 100 gig, the black one. And between ECI and Ixia is also 100 gig. So in principle, as the control setup would be, we will be running 100 gig traffic from this test point to this test point. And in this 100 gig, there will be 5 tunnels, and this will correspond to 5 VLANs. So, for example, VLAN 1 will be 5 gig, 2, 10 gig, 3, 15 gig, 4, 20 gig, and the 5th one will be 50 gig. On the first step, we will run this, and this will be without packet drops, of course. And on the second step, we will oversubscribe the VLAN 5, which is the 50 gig. We will oversubscribe from here by having this additional interface to the test equipment. From ECI, this is a 10 gig link, and from Huawei, this is a gig E link. So what is the purpose? We'd like to show you that when we oversubscribe tunnel number 5, it doesn't affect the other tunnels, tunnels 1, 2, 3, and 4, because we are doing hard isolation. So when you're doing, in principle, if you're doing hard isolation or hard slicing, if there is oversubscription on one tunnel, it shouldn't affect the other channel. So that is what we are showing here. So first step, we will show what we have in Ixia. Here we are looking at the IX network from Ixia. So this is their dashboard. And here we can see that the traffic is already flowing. Basically, like I said, we have 5 VLANs with their corresponding bandwidth. In total, there will be 100 gig line rate in between Huawei and ECI. You will see here that there is no loss, and if we stop so that we'll see that there is really no packet loss. So after running for 2 minutes and 39 seconds, we see that there is 0 loss on all the 5 VLANs. And the frame deltas is also 0, and so on. So here, down here, you will see this is the oversubscription. The oversubscription will run through VLAN 5. So we will oversubscribe VLAN 5. And in the next step, we will see that we will see the packet loss only on VLAN 5. And for VLAN 1, 2, 3, and 4, because they are hard isolated, so there should be no packet loss in the other VLANs except for VLAN 5. So now it is running, so we will let it run for a while, and we'll see later how much packet loss we have. Now we see here that 1 minute has already passed, and we see that VLAN 1 to 4 had 0 packet loss during this time, and as expected, it's only VLAN 5 that has or experiencing packet loss because it was oversubscribed. So there you go, hard isolation, FlexE. Thank you very much.
Thank you very much for presenting, Ilya. It was a pleasure to test with you and the ECI colleagues and everybody from the FlexE team. And we will always memorize that you jumped in at short notice and supported us in an outstanding way. Thank you very much. And for the audience, I look forward to seeing you again in the upcoming remaining demonstration videos. Thank you.